Yo, what's up? I'm here. I'm here again. We're gonna do this. Should I talk about that? Yeah, let's talk about that. Okay. First of all, what did I just Google? Twitch viewers. I can't spell. God dang. Let me go to history. Uh, okay, so I googled this because for some reason at the start of my stream there's always like two people, two viewers that show up and immediately go away within like 10 seconds. And of course, since I'm a small channel, I'm like, oh no, what did I do to insult them? What happened? Do I need to just immediately not have any opening? Possible. Could also just be like bots that whenever a new stream starts, they go in and, I don't know, gather information. I think that's more likely. So I came here, right, and I'm like, 5 reasons no one's watching your Twitch streams. I'm like, alright, I've probably heard all these before, right? You're just starting, so you don't have a community. You don't have a schedule. Well, I did a schedule, still didn't work. No communication, I communicate. Your stream isn't about your audience. I don't know what I could do more. And then here's the kicker. All right, here's the kicker, right? You need to ask yourself one important question to do with promoting your channel. How can I make this person's life easier or better? With established channels, right? This is about being real. It's about being a real person with real emotions and actually caring for the well-being of others. So basically, be nice to other streams that are established, and they'll give you viewers. If you're doing it with that intent in mind, how exactly is that real? Also, I don't think that's gonna work. I really don't think that's gonna work. Provide value to other people's lives and you will see it come back to you. Based on what? Like, is this some karma nonsense? And then I'm like, who wrote this? And I'm like, oh, it's just one guy, isn't it? It's just some random dude's opinion. Completely not related to programming a rhythm game, but just thought I would say that's how I started off my morning, being pissed off at this random article. But more importantly, I want to show you the contents of my Google Drive. Here, look at NetBeans. All right, now I do want to show you the contents of my Google Drive. All right, we got this stuff going on, and we're gonna come back to this document in a little bit once it loads. We're currently in the process of testing the .sm parser. We made amazing strides yesterday. Oh my god, did we make some strides. We basically have a working parser. It will parse BPM changes that happen between beats. However, there's still some small errors that happen and accumulate. And I have an idea of what they might be, but basically, we got 20 seconds. We got perfectly through 20 seconds of a song. With everything being perfectly accurate, right? And we found a bug and we fixed it. Still not perfect all the way to the end. So basically, we just gotta keep going and find the next error. And I think I know what it's gonna be, because I was thinking about it last night. I think I know what the error is. Let me start the development time. Oh, also I fixed, you don't see my mouse currently. I don't know why. Or I can't see you seeing my mouse. Okay, here's my mouse. Down here, down with the now playing thing, I fixed that. So it's not going to keep going on to the next line. At least in theory, it won't keep doing that. That's exciting. Kind of unrelated as well. Start the timer. Here we are, sitting pretty. 16 hours of development. This is supposed to take 32 hours. So we have 2 days to figure this out. I don't think we'll have a problem, but then again, I could be mistaken. Also, I made the text bigger. I stream it at a relatively low bit rate, so that's why it's gonna look blurry. I can't increase my internet speed, so the best I can do is make the text bigger. Navigator? You need to go away. Okay, here we go. See, this way I can actually have a proper amount of reading room. And it's gonna get hard. It's gonna be hard to get used to in the beginning, but it should be fine. I'll get used to it. Where were we? We are at parse header. No, we don't need to parse the header. We're all good and done with parsing the header. We need to parse the notes. Still haven't. I'm just gonna delete that. We don't even need to care what measure we're on. And we can, yeah, we use line number. Yeah. And then we do this. I love this line. Still love that line of code. It's still awesome. And then we print out all the note information here. And note.toString is still super sexy. Alright. So we run it, and we gotta, let's take a look at the new output. Yep, it's shocking that that's not a bug, that it takes so long. BPM changed. Oh yeah, okay. The BPM is changing in a place where there's no notes. That's the cause of this. It's gonna take forever. So we made it to the 20-second mark, and everything's great. Everything's good. What I should do, actually, is put this chunk in a notepad document. Yeah, let me show you what I have in the notepad document right now. I have this. This is all the times. These are the correct times for the notes. And if there's more than one note on a line, I just ignore that. So we need to be able to get here correctly. And everything up to 12 seconds is good. But what I want to do is put like the 19-second area here, because of how important those times were for us. And to do that, I open ddream, which you don't see because I can't be bothered to set that up for this stream. It's not important. All you need to know is it's a program that gives me the correct times for the notes. It's an established thing that does parsing already. Which, without it, it would be completely impossible to test this. So we thank God that it exists. Okay, 20-second mark. Show it to me. Alright, so we have a note at... Does that look weird for you guys? No, it doesn't. Okay, all good. 19.936. $20.227. This is the one that we got right just now. And it happened because there was a BPM change on a beat, on a note. Okay. And presumably there's going to be a ... because we're gonna skip ahead a few until we find a discrepancy. But what we do have, let's go check. Okay, switch over to NetBeans. Okay. 19.36 or 936. That's good. 227. Beautiful. 518. Awesome. 628. Look at this. Look at this. Look at this. Look at this. Look at that. Look at it. Look at that. Look at that. What does that tell you? There's a BPM change at 35. I bet you. I bet you. How much do you want to bet? I bet you that's the case. I accept your bet. Whatever it was. What did I say? At 35. Show me the BPM change at 35. Right there it is. Do you see? Give me the money now. Whatever you bet me. Hand it over. Okay, this is exactly what I was thinking about last night. Okay. Somehow, magically, I don't know how, but we were able to change a condition, and we changed a less than or equal to, or we changed a less than to a less than or equal to, which registered this BPM change right here instead of after these two notes. Because this is exactly equal to 34. This should be exactly equal to 35. But it's not because like an actual error in our parsing algorithm. The other one was a logic error. But this is simply because of like division and rounding nonsense. So what we need to do is less than or equal to or equal to within certain margins, right? Uh, okay. Yeah, okay, it happened right here. All right, so what I'm gonna do, I'm gonna copy this. Um, I'm gonna copy this. I'm gonna have a think. I'm gonna have a think. I'm gonna have a think for a minute. And I'm gonna think about what it should be. Right? Okay. I didn't copy everything I needed. I'm dumb. Here, let's not be dumb this time. Here we go. Okay. Before okay, you can fuck off DD-Ream. DD-Ream likes to eat your inputs, so if you say like Shift B, it'll think you're trying to give it a command. Okay. So the absolute value of their difference should be within a certain tolerance. How the heck do we decide what that tolerance should be? I have no idea. Oh, also what we can do, okay. I'm curious. What I'd actually like to do is, do I need to copy all this? Nah. Okay. Here's another example of where it should detect a BPM change, but it didn't. Okay. Let's go. Let's go take a look. Look at how tiny that is. Do you see how tiny that is? That's so tiny. Okay. I want to do something fancy. Because that error amount, seeing it's on the order of something related to our scale, right? I think. So if you take the well, how many decimals is this? There should be 50. I'm not sure if it's gonna be 50 or if this is 50 or if altogether it's 50. I guess altogether it's 50. Yeah, has to be, right? I'm not sure. uh, did I set my scale to 100? I must have, right? I did. Let's put it at 20. The same error will happen. It'll just be shorter strings. Much shorter strings. We're right around here. Yep. It's 34.9 repeated. Yeah. Okay, so this, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the scale is the number of decimal places, it seems. Which means the following. If we go over here, 20 minus 3 . So I think I should do 20 minus 4, which is 16. So 10 to the minus 16. I don't need a squared button. I need a raise to the power up button. Okay. Here we go. 10 to the power of negative 16. Where's the negation button? There. Has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 zeros in front of it, and then a 1. So if I say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then a 1. We don't need that much. We could just put the 1 here. Or maybe we should put it here. Let's put it here, right? So 10 to the power of scale minus 4, negative scale minus 4. Right? You still looking at the same thing I am? Yes, you are. 10 to the power of negative scale minus 4, or negative. This is really smart. This is like scientific nonsense that's happening right here. Okay. Okay. Sweet. It does accumulate. The error indeed accumulates. In theory, this will be enough, but I'll definitely put a note that like it's likely to desync if it's too long. Let's put 5. 3 is actually what's necessary. 4 is just being safe, 5 is being super safe. So let's be super safe, right? And then let's hope that it doesn't like give false positives. Now I need to know how to produce this number. Which will require me looking at the documentation for big decimal. So I just put a negative number here. Set scale, and then scale by power of 10. Sweet. Do I want to make that calculation every time? I don't think I do. Let's make that calculation outside of this method and pass it in. We don't need current beat, so let's do a little refactoring. Here you go. It's the only places where it's used. Big decimal dot one. New big. Oh wait, no. Yeah, I can just do like dot set scale dot scale by power of 10 negative scale minus 5. Boom. Did it. Oh, let's do this. Int. What's your problem? I just used it right there. Yeah? Yeah, it is. And it should be. Oh. Oh, duh. Of course. Great, and I'm going to pass this in to ppm changes. Dot error margin. Or comma error margin. This is so great. This is awesome. Okay, this is totally going to work. I'm gonna double check whether Big Decimal has like has a method built in for like being equal within certain bounds. I wouldn't suspect it would. That's fine. Yeah, no, it doesn't. We don't need it. Or if it's another definition of equals, the absolute value of their difference is less than error margin. That's not how you compare things. Oops. That's how you do it. That should work. Hold on. Still a bit sick, so that's gonna keep happening. Sorry. If their difference is smaller than the margin of error, save. Please, God, work. Please, oh dear God, please work. That's hopeful. That's really close. That's hopeful. That's hopeful. That's not quite right. It's really close though. And if we fool with the error margin, we might be able to get it perfect. That's really good though. That's really good. Okay, let's go see if we fix the specific error we were thinking about, which is at 766. Not perfect yet. What was it? It was 34.99. Okay, let's look at our notepad document. The BPM change should come before it. The 0.99. It does. It does. Means we did it. We fixed this error. And that means this should be the correct time, huh? .518. Yes. 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 Oh my god, yes. That's so great. Okay. Next, we should start comparing one by one until we find the next error, which, as we know, there can't be that many of. Yes. Oh my god, I'm so excited. Okay. Okay. Come here, DDR. This is gonna be such a hard thing to explain. How can anyone possibly understand this nonsense? Oh my goodness. Okay. God, I'm so excited that that worked. It worked how I thought it did. Oh, I'm so glad. Oh, okay. So at the 20-second mark, 20.227. Perfect. 20.518. Perfect. 20.628. Close enough. 20.664. Yep. 20.713. Yep. 20.870. Yep. 21.101. Yep. 21.198. Yes. 21.246. Yes. 21.392. Yes. 21.538. Yes. So here's another. Let's see. Let's see if it handles it. 21.538. 21.635. Yes. 21.683. Yes. 21.780. Yes. 21.926. Yes. 21.975. Yes. 22.120. Yes. 22.145. Yes. 22.266. Yes. 22.557. Yes. 22.848. Yes. 22.994. Yes. 23.140. Yes. 23.285. Yes. Interesting. 23.285. 23.431. Perfect. 23.479. Yes. 24.305. Yes. And then there's a long gap. 25.761. Yes. I'm so happy right now. 26.222. 26.344. Yeah. 26.635. 27.096. 27.217. 27.509. Oh my god, I'm so happy. Okay. Let's skip ahead. Let's do 60, around 60. Well, let's do this. Okay. Hmm. $60.713. There's a 0 and a 3. Well, that's weird. In the in DD-Ream, these wait, what? It should be 0.3. Oh, it is. Okay. Yeah. 0.3. These two notes are are so close together that they're not even a millisecond apart. That's weird as all get out. Is there error after this moment? That's so weird. Would I have to like reduce the margin of error? It's very strange. 61.101. 0.001. It's still accurate. It's still accurate. Mine is maybe even more precise. Oh wait, no. No, that's right. That's fine. That's actually fine. Yeah. No, that's good. It didn't it had a very strange way of scrolling through the notes. 61.001. 61.173. Yeah, fucking beautiful still. 61.295. Amazing. $90. $89.547. Oh, that seems wrong. 18,000 BPM. Interesting. Weird. So weird. Okay, let's go to the note before that. 89.256. Huh, that seems way wrong. Which note should 89.2? It's either this note or this note, but neither of them are particularly accurate. Let's go. Let's go to 75 seconds. $74.111. No, not quite. Weird. Weird, weird, weird. $67.995. And 68.164. Ugh. Oh wait, it's another one of those weird 67.994. No, that's correct. And then these two notes are at different places slightly. But they're both close to 164. That seems correct. 67.874. That seems not correct. Wait, what? Huh? 0.703. Yeah, no, that's not right. Am I sure that this stuff was correct? That's correct. Mm-hmm. And then this nonsense happens. Alright, I'm gonna write down the... I'm gonna put them into Notepad, though. Because this seems to be where things get interesting. Okay, that's probably enough. This is so weird. don't know how I'm gonna fix this. 60.713. 60.714. 001. 173. 295. 591. Also 591. 878. 048. 196. Or 169, excuse me. 460 751 043 225. Well, that's a problem right there, 225. Three three four 504. Yeah, everything else is slightly off after that. Okay. Maybe there's a double BPM change and there shouldn't be. Right there, that's the problem. Okay, 108. That's a problem. 108 feet. Let me look at, let's look. $108. Oh yeah, weird stuff is happening. Oh my god, everything is happening. Do you see this? Look at that. At exactly 108, there's a BPM change, that's good. Okay. My program considers we successfully registered this BPM change, I think. But then there's another BPM change at 108.313. And then at 333. Yeah, and what's the problem? Why? Look at that. Why would that be an issue? There should be 2 BPM changes right there before you get to the next note. And there's a note exactly on the 333. So the note that's at beat 108.3 something should have BPM 1002. Hypothesis. It doesn't for some reason. Oh wait, no, yes. No, I was wrong. It shouldn't have 1002. It should have 92.6081, which it does. I don't know whether... See, I don't know whether this is a problem with my program or a problem with their program, honestly. There should, and there is, be two BPM changes. I don't know whether they register too. I honestly can't tell. Maybe I can tell. Let me see. 63 point something something. Oh, further back, further back, further back. 62.751. Yeah, close enough. 63.043. Yep, it makes sense that there's two because it's a double. Then there should be two BPM changes. 63.043. They say it has 102.999. It does. I agree. I agree with that. And then I'm looking at their BPM. How can mine be so far off? They say that the next note is at 63.22225 or 226. Can I like zoom in further and see? 226 it looks like. And it looks like they're saying the note does have 92.608 BPM. Hmm. I'm gonna have it do some math for me. Freaking gnat. Wow. Two Plain Street. Ah, look at this. BPM changed, it added this amount of time. BPM changed, it added this amount of time. And then it should add one more amount of time as well. Which sure, I'll print that too. Make it even harder to find what I'm looking for. Yeah. Well, I should just copy the print statement. Wow, okay. $63 point something 225. Wow, okay. There's actually a lot of additions that took place. Oh, geez. Why? Oh, because there's a bunch of lines, and this is there's 96. So there should be 0, 1, 2, 3, 4, 5, 6, 7. I feel like there should be 7 of these. 1, 2, 3, 4, 5, 6, 7. There's 8. Is that okay? Does that make sense? Well, this one is associated with the BPM change, but it's the exact same number. If there is an off by 1 error, we definitely would have noticed it, because these are not insignificant numbers that we're adding. Yeah, we would have noticed this size difference way earlier. But is that roughly the size of the difference that we're looking at? Should be 63.226. So 63.238 or 9 minus 63.226 is 0.013. Not 0013, 013. Which isn't the size of any of these numbers. This is like 10 times too big, or too small. This is 100 times too small. And this is 10 times too big. 013, okay, no, this isn't 10 times too big, but... Hmm. Oh, 43. 238, it should be 225. Still off in the same way. I also still don't know why this number is the same as this number. Is that common? It must be that this is like printing where it's not supposed to be, which is weird. Because this one definitely goes with this one. This one goes with this one. That's just a printing idiosyncrasy, I guess. Never mind. Why are there 8? $12. 84 minus 72 is 12. Okay. Seems normal. Yep. What if I reduce that to 3? That's a negative. That's not okay. .225. It's still not right. It's very strange that there's negatives. What the heck? Yeah, there are for sure negatives over here. Which still doesn't give me a correct time at the end. Oh well. Should still be 116. Something. Right at the start of the measure, there's a 0 position and a 3 position. Oh, yep. 0, 1, 2, 3. Right there, yep. And then later on, there's a 1 position. Yep. This is everything. This is the whole everything right here. Okay. Look, here's what's gonna happen. Here's what's gonna happen. I'm gonna calculate this by hand. And make sure that my program isn't actually doing something I don't want it to do. If we determine that the program is not doing something that I don't want it to do, then we're done. Or if we don't determine that, then we're done. My god, not that far. Okay. Here's a much more manageable string. Here's an even more manageable set of strings. Copy some stuff over. There's the program output. Okay. Line number, current beat, and this is the BPM. Okay, how do you calculate BPM after all? Let's copy my little note over. Okay. 1 second. Actually, I gotta go to the bathroom. Slightly longer than 1 second. I'm back. Who's texting? Nobody. Just people uploading videos. Who cares? Aha! Gonna do this the old-fashioned way. Which may or may not be awful. So let's look at our actual notes and copy them over as well, actually. Here's where we actually, okay. This one is okay. This one is okay. This one is not okay, I think. And this one is also not okay. Right? We don't care about that right now because we don't have the time for it. But 62.7520. $63.0432. 63.2388. Good. We don't know that one. What do we know about this note? It is 84th in a group of 96. This would only ever go to 95, right? I think that's right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That makes perfect sense. I'm with it. I get it. I get it. Okay. What's the beat that it's on? Does it make sense that that's its current BPM? Um, 107.5. Yes, of course. Okay. So now, what's the formula? Next beat minus current beat. Okay. So it's 1 over 96, right? No, it's 4 over 96. Because it measures 4 beats. So it's 4 over 96 is the number of beats. Times 60. And the BPM doesn't change by the time we get there, right? Well, wait, okay, let's do different order. First, calculate what beat we're on, right? So it should be 107.5. How many zeros? 6 zeros. Great, awesome. Okay. And we're adding to that 4 over 96. So the beat here is that's just what the calculator gave me. Okay. I should really just be doing this in Excel. Which I will now. Hold on. Beats, BPM, seconds. Okay. Okay, great. Okay. So I'm gonna add I'm adding that. And I'm going to do that for some while. Until when? Until we reach 108. Which will happen when? Ah. Which will happen right here, I believe? Oh. Hmm. I'm struggling to wrap my mind around what the numbers mean. So, this note is on beat 108. Yeah. This note isn't on beat 107.5. That's what beat will be happening like after on the next beat, on the next note, I mean. Which begs the question, is the first note at 0 beats? I guess we wouldn't really know that because there's no note at the very beginning. Oh, of course we wouldn't know that. How is this note not on the wrong beat? Oh wait, everything's fine. I'm just a moron. Oh, thank God. That's fine. That's fine. That's fine. Okay. Yeah, so technically this shouldn't be here. This extra little bit. This is only here because of this rounding error. But other than that, that's fine. Because this is insignificant compared to that. And controllable. Okay, so no, this is not where there's a problem. This is fine. This is good. Okay. This is just test stuff. Okay. Then the BPM doesn't change. Until here, where the BPM is now. Doesn't look like it lines up. But it must. Oh. Sure, okay. Now it lines up. Great. God, awesome, good. Okay. So the BPM here doesn't change. For a while. Even here, it's still the same, and then it changes, right? Yep. Okay. And now the new seconds should be the following. Oh, these are, yeah. I have an Excel spreadsheet. while I'm doing this. Okay. So now it should be the previous number of seconds plus 60 times the difference between this beat and the previous divided by the BPM. Okay. And just to be clear, I'm gonna put another box where it says how much it added. And we can just match that with all the numbers that were added. We can match that with this. It should just be constant. O243 O242 O242 716 0901. Oh, of course it differs because it's significant distance. Yeah, okay, that's fine. Yeah, and it will be the same all the way down. Of course. So we have I have 11 of those. Does that make sense? One, two, three, four, five, six, 7, 8, 9, 10, 11. Okay. So it should give us, okay. The difference between this and 108. Well, but okay, so you get from 107.9583, you get from here to 108, right? So it should be 63.0190 plus 0.02427 plus oh no. 0. Lots of zeros. How many zeros? 1, 2, 3, 4, 5, 6, 7. Yep. I get 236. Shouldn't make a difference. Divided by so the BPM, the new BPM is going to be 102.999. Which will give us 63.0433. 0432. We're good. It's fine. Okay. And then now I gotta get there. Okay. When's the next BPM change? 313. Okay. So 4/96 is what we're adding. And we keep going until we get to 313. Or roundabouts 313. Okay. Which should get us to basically it gets us to right here. But then there's BPM change right there. Okay. 0.041 6, 7 8 3 3 3. Let's just do that. 1250 1667 2083 2500 2917. Right? Same BPM across the board, right? Yeah. BPM isn't changing here. And it won't until 313. Okay, what's the seconds? Okay. Okay. So it should be 62.2132 plus well, how long does it take to get to 313? 108.313. Okay. So 108.313 minus 108.2917. Oops. Is 0213. So 60 times divided by the current BPM. And then the BPM changes. And how many beats do we have of that? Jesus. That was annoying. 313 until 333. So 313 until 333. Which is 0.02. What's the new BPM? 1002.27. And then the remainder to get to here, which for me has a 4 in this last place, but still. Okay, that's a pretty small number. And the new BPM here is 92. 6081, I think. Yeah. Okay, let's actually put the numbers down for this. Okay. Aha! This is wrong. And this is the reason why. That calculation was done wrong by the program. It just gave it the regular, which is roughly twice that. It just gave it that. Am I sure about that? Okay, why? Okay, let's think of it in terms of the program now. We found another bug. That's so good. That's awesome. Okay. Let me think. Okay. The program should have current beat as Next beat should be um, that, roughly. Okay. However, it can't get to next beat, obviously, because 313. There's a so then mid beat is 313. Okay, and then mid beat. And then another mid beat is going to be 108. Point 333. Okay. Let me see if I can get it to tell me that information. Maybe this should come first? Let me think. Yeah, why would it do that? That's not right. That doesn't seem right at all. We're trying to get to the next beat. If the BPM changes from current to next beat, don't do current time first. Um, no, this isn't entirely necessary, but it makes me feel better. Kind of explains things. Okay, what if I did that? How wrong is everything? 63 seconds. Oh, this looks very wrong. Yeah, that's way wrong. Okay, something is wrong with my understanding. And with my code. But what's great is, well, hold on, let's undo. Great, okay. Is that right? Or is that where we were before? Yes, yes. It is just as wrong as before. It's 2388, it should be 2327. Okay. 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 Let me run the program in my brain. While referencing the notepad document. Hmm. Oh. That's not a smart place to put my phone. Okay. So we go ask BPM changes. Hey, does the BPM change for next beat? So what does it do? Well, the next BPM change happens at, in our case, 108.313. If 108.313 is less than next beat, which it is, then the BPM is going to change. What should it do about that? Well, this is what I think it should do, not what it was doing previously. I think it should. Ignoring the print statements. Say, hey, mid beat is next BPM change, basically. Add an amount of time using the current BPM, right? Next beat subtract mid beat. No. No, it should be mid beat subtract next beat, right? Mid-beat subtract current, excuse me. Yeah, this wasn't right either. What the fuck? How is... And then current beat equals mid beat. Let's see how wrong I am. Uh, 62, 63.0, 432. Oh, what the fuck? Is that right? Is that... I think that's right. Oh my god, I think it's 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 right. This doesn't look right though. Is the last note right? That's the real test. $116.480. Fuck. It's really close though. God, is it close? Okay. Now here's where we do something stupid. Really no change. It's still 63.227. Is that what was that correct all along? I want to make sure that that was the number we were looking for. That was the number we were looking for. Okay, what if we bring it back? Bring it back. Bring it back. Or 116.480. I wrote that down in the notepad document, didn't I? Yeah, that's the dream. Still not correct. Still not correct. Still 63.227. Weird. That's really weird. And it's also slightly off, like it should be 225. But that's what I got when I did my Excel calculation. Yeah, everything's like 0.002 off. Weird. What if I, bump the scale up to 20? Still wrong. Well, if I increase the error margin to 5. Oh my god, it's the exact same number every time. And if I completely get rid of this and this, still the same. Alright, we're gonna leave it like that. Until we need to not have it like that. Okay? Because it doesn't make any difference either way, it seems. Which I don't see why it should. So, that's good. Oh, that's so weird. Okay. Well... I wonder if this is exactly where I was before. Because it's kind of discouraging that I clearly had the wrong algorithm all along. I'm getting the exact same number that I got before, the 524. What the hell? I'm getting the exact same numbers. Oh boy. Alright, we are officially in the same place that I was. I don't know. A few months ago. Because I wrote a Java parser and it did the same thing. Which is, it's cool that I have managed to write equivalent code, but it's not cool that it's wrong still. Wrong. Yeah, whatever that means. Oh. What is that BPM that it spikes to? It spikes to 1,000 BPM. 1,002. I did the math, like, right here. This is how many beats to get to the next BPM change. The one that's at 108.313. Yeah? Oh yeah, because we already we do all this stuff. Right? So we're basically here. Right, we're here at this time point. And we're trying to get to this, or not time point, number of beats. We're at this number of beats and we're trying to get to this number of beats, right? There's 2 BPM changes in between here, right? One of them is at 313, one of them is at 333. So this is for the one that's at 313. And this is for the one that's at 333. And the error is on the scale of this. Or on the scale of really like twice this. This plus this, probably. Two, 2, 7. So it's the third. Yeah. It's as if it doesn't do those BPM changes at all. It just does this, which is... Well, what is that from? That's from the original BPM. That's the 102 point... That's the 102.999 BPM. It's as if it doesn't even register those BPM changes. Oh my god. Why would it not register those BPM changes? Okay. The only reason I can think of why it wouldn't register those BPM changes is because for some reason a BPM change happens earlier. Like over here. I guess I could visually see that in there in the editor. I think we looked at it and that wasn't the case. It did the BPM change where we expected it to do the BPM change. That's what I thought. .043. Let me zoom in even more. 63.043 is at beat 108 point something or other. What time point do we get to? This is interesting. Okay. .2917. Am I crazy? Oh, yes, I am. 2132. So at 2132, we should still be at the same BPM, which we appear to be. And then there should be 2 BPM changes. There's one. Like I can visually see one. And there's another one. Right on it. Hmm. Yeah, it has the right BPM. Oh, because of course it would, because for me it comes slightly after. Weird. Hmm. You know what's weird? I think it's possible that DD Ream does something fundamentally different. I think that those BPM changes, the beat at which they take place, um, I think what we're given is not 100%. That like DD Ream assumes that a BPM change can only take place on a what is it? A basically what is it? A 48th note or a 192nd note? 4 beats divided by 192. Every BPM change can only happen on increments of that size of 4 over 192. Because I'm looking at their thing where I could set it to snap to 192nd notes, right? And the BPM change is exactly on the line. Like, completely precisely on the line, no matter how far I zoom. Weird. Yeah, that's just a completely different way of calculating it. And I also don't know why there's 4 slots between those 2 BPM changes. Yeah, it's so weird. Because my program is doing the math correctly. The only way it knows how. There must be something that DD Ream is doing that my program will never do, I'm pretty sure. Weird. It's really weird. And I don't know how to fix that other than, like, representing my beats as fractions, fractional values. And then why were there 4 ticks? It might also just be an error in DD-Ream, as silly as it sounds. Like, there were... I don't understand how there were 4 ticks after the VPN change. Oh, hello, Joel Games. I'm doing a lot of thinking. Also, I was just looking at a window with DD-Ream, which I didn't show you. Okay. Well, this is very strange. This is not a situation that I expected. Weird. Alright, let's make some changes. We have discovered that we don't need a margin of error because it doesn't change the result at all. Well, I don't know, maybe. Do we want it? Do we need it? Do we care? Oh, this. Is that the right BPM? '34, 35th, the 35th beat. Should be 103. That is clearly not 103. Okay. If I do... If I do that, we'll have the correct beat now. Or correct BPM. I suspect it will. $35. Interesting. Weird. I don't know. They gave it the right BPM, but um, it should detect a BPM change if the note or beat that you're trying to get to has a BPM change right on top of it, then you should get to a different BPM. And BPM change is the only way that you get a different BPM. Yeah, so it should consider less than or equal to, and if it should consider less than or equal to, then it should consider less than or equal to within a certain margin, because we understand that our little thing is a little bit off, and that results in a negative. Excuse me. That results in a negative. Okay. Why? Why does it result in a negative? Why does it result in negative? Well, I suppose normally it would result in a 0. Like the difference between them should be 0. Right? Ooh. That is making an assumption. Why would equal to... Okay. The only reason we know... The only reason equal to is significant is because we know that BPM changes can happen exactly on a note. That's the only reason that we know that. Okay. It's what we learned basically is that BPM changes they don't necessarily only happen on notes, but they well, I don't know. But if you're at the 192nd note level, then every BPM change can only happen on a yeah, because we are right here. Can only happen on a note. In which case, so normally that shouldn't be there. In a world where BPMs aren't restricted, that statement would be unnecessary. But in the world that we assume we're in, we can use this information to do a correction of current beat. Which I don't think we can do in here. Crap. Well, what can we do? Well, we know, okay. We could do a check here. I'm actually just curious if by fixing that, we'll get the exact right time that we're looking for. I'm very curious. Okay. So we will do the following. If dot sign if their difference is negative, then set them equal. Should not significantly change anything. But what it might actually do shouldn't be having negatives anymore. That's annoying. Five, two, four still. The hell? Right? Is that the same? Yeah, that's the same. What was that? Beat 30? Yeah, right here. This shouldn't happen. That should be 0. Oh, it's printing it before that actually happens. So that's not actually the correct value? Okay. But, okay. That's... That only accounts for BPM changes that are on notes. If every measure was 192, if every measure was 192, then this would work perfectly. That's my hypothesis. Because then every BPM change would be, yeah, look, the BPM change happens, there's a very tiny difference, and it's 192. BPM change, not tiny difference. because 16. That makes sense. Yep, that's it. That's it. Okay. This won't, it's not worth our time to have that in there. So in fact, we're gonna go ahead and get rid of the significant, the error margin thing. Because it doesn't do anything. Wait. Oh. It doesn't do anything. Scale only needs to be like 10, honestly. What's your problem? Oh, yeah. Error margin not useful. No longer useful. And therefore neither is this. Yep. Run it again just to make sure. Ah, yes. So this logic is bulletproof. It's correct. It's perfect. I could probably simplify it, but let's not. Yeah. No, it's fine. It's good. Run it. Because if I simplified it, that would actually make it a lot harder to read. And this should be 054 or something like that. 524, yeah. This is actually the correct number. That's like the best that this method can do. What should it be again? Like, how far off is that? 480. Okay. So that is 40. It's 44 milliseconds. By the end. It's 44 milliseconds off by the end, which is, well, how much is a frame? If we're running at 30 frames per second. That is, well, yeah, that's a frame. That's a 30 FPS frame, or two 60 FPS frames. A little bit more, in fact, than that. Well, that's kind of annoying. But we'd have to switch to a whole different system of parsing. Which is interesting. I don't want to do that. I think it's fine how it is. Yeah, okay. That's very interesting. Okay. I'm so glad that I figured out exactly what was going on. I'm pretty sure I know what's going on and why all that happened. Okay. Here's what's gonna happen. I'm going to take a 1 hour break to eat and stuff, and then and then I'll be back for more. We're gonna comment and document all of this stuff, and probably talk in the document about what the limitations of this system are. See if I can explain that properly, and then we shall move on to the next part of the project. All right. Awesome. Okay. The exciting conclusion when we come back. Thanks for watching.